This standard is about using scientific notation. We'll start by turning regular numbers, which are also called decimal numbers, into scientific notation. Then we'll go from scientific notation back to decimal numbers, and then we'll do some arithmetic with multiplying and dividing in scientific notation. So first of all, here's a normal number, 3,124. To put a number in scientific notation, you need to start with a number between 1 and 10. So I take this number, there's a decimal point after the 4, and I keep moving it to the left till I'm left with a number between 1 and 10. So there, this right here. If I move the decimal point to there, I have 3.124. And I can't just change a number like that. So what I need to do is multiply this number by 1,000. When you multiply a number by 1,000, that means you move the decimal point back over 3 to the right. So that means I would have the same number I had before. That doesn't look very clever, does it? 3.124 times 1,000 is 3,124. Where it gets interesting is you change 1,000 to 10 to the third, because 1,000 is 10 times 10 times 10. So I'm going to rewrite this as 3.124 times 10 to the third. And that's scientific notation. You turn the number into a number between 1 and 10 multiplied by some power of 10. It seems kind of silly, but it's useful if you have a really big number, like 4 million something. Instead of writing out all the zeros and getting this giant number, you can write just the few numbers at the beginning, which tell you most of the important information about the number, and then what power of 10 it is. Scientists use this all the time because many phenomena in nature have to do with really big numbers, like the distance from the Earth to the Sun. And it's much easier if you don't have to write out this big giant number, just the first few digits, and then what power of 10. So here's a number like 12. I'm going to change this into scientific notation by writing the decimal point after the 2 where it goes. Move it over 1 to the left. Now I've got a number 1.2 that's in between 1 and 10. So 1.2 times, how many did I move the decimal over? 1. So I only need 110 times 10 to the 1. The same principle works for very small numbers, except I already have the decimal point here. And now I'm going to move it to the right instead of move it to the left until I get a number between 1 and 10. So 1, 2, 3 places. I've got 4, which is a number between 1 and 10. So I have 4 times 10 to the, this time I need a negative number. I moved it over 1, 2, 3. So 4 times 10 to the negative third. Let's try one more decimal one. I start here. Move over 1, 2, 3, 4 to give me 3.51 times 10 to the, I moved it over 4, so 10 to the negative fourth. Now we're going to take a number in scientific notation and move it back to a regular number. So I'll start by writing the 6.71 times 10 to the third. That means I moved it over 3 to the left, so I'm going to have to move it over 3 to the right to get back. 1, 2, 3. One more. That means I have to add a 0 at the end. So this number is 6,710. Same basic idea if it's a small number, except you're going to go in the other direction. So 5.72. To make this into a decimal, I have to move it back to the left. So I'm going to move it 1, 2, 3, 4. Decimal. I have to put in zeros to fill in these holes. So this is the same as 0.000572. Now let's do a little bit of arithmetic with scientific notation. 3.1 times 10 to the fifth multiplied by 4 times 10 to the second. People usually put those parentheses around them to make it obvious which is the whole scientific notation number. So kind of similar to doing operations with exponents that have a lot of variables in them. You take the stuff that's in common and you work with that. So 3.1 and 4 are both numbers. 3.1 times 4 is going to be 12 and then 0.4 times 10 to the This was 10 to the fifth, 10 to the second. When you multiply exponents, you add them. So 5 plus 2 is 7. For division, same deal, 2 divided by 8, uh-oh, that's going to be a part of something. That's 1/4. It's not usually good form to mix fractions with decimals, so I'm going to turn 1/4 into a decimal, which is 0.25. And then when you divide exponents, you subtract them, so times 10 to the second. This number has a problem though. 0.25 isn't between 1 and 10, so I'm going to move this decimal over 1 to the right. When I did that, I made 0.25 into 2.5, so I made that into a bigger number. In order to balance the whole thing, I'm going to take 1 away from 2 and turn that into a smaller number. So this turns into 2.5 times 10 to the first.